Hello grade 8 learner! Welcome again to another mathematics video lesson. In this lesson, we will be learning how to factor polynomials through grouping. This is a method that you can use in any type of polynomial that you have to work on. So, grab your pen, paper, and module as we start watching and learning from this video lesson. Happy learning! This lesson is based on the K-12 curriculum learning competency. The learner factors completely different types of polynomials. By the end of this lesson, you, the learner, should be able to recognize polynomials that can be factored out by grouping, follow the steps in factoring polynomials by grouping, and of course, to apply the steps in factoring polynomials by grouping. Let's begin the lesson. In our previous discussions about factoring, we have been factoring monomials, binomials, or trinomials. So you have to ask, how about polynomials with more than 3 terms? How do we factor them? For this video lesson, we will be focusing on the method to factor out polynomials with more than 3 terms, and that is factoring by grouping. If you're going to factor polynomials with more than 3 terms, then we're going to follow the pattern as shown here. If you notice, common factors are separated and used as terms in a binomial. Take a look at the following examples. To factor polynomials by grouping, we follow these steps. Given the polynomial ab minus 2ac plus 5b minus 10c, the first step that we make in factoring this polynomial is to group together those terms with common factors. To do this, we take a closer look at each of the terms in the polynomial. We can see that the first two terms, ab and negative 2ac, have a common factor which is a, while 5b and negative 10c have a common factor which is 5. Thus, we group ab and negative 2ac together and 5b and negative 10c together. In doing this, we are applying the associative property of equality, which means that the grouping we did does not affect the value of the expression. Also, we can have a different grouping aside from the one shown here. If you observe, negative 2ac and negative 10c can have negative 2c as a common factor, while ab and 5b has b as their common factor. We can also use that grouping. But for this solution, let's just stick to the grouping that we've already made. After grouping the terms, we then factor out the GCF of the group terms. We apply here what we've learned in our previous lesson in factoring using common monomial factoring. So in our first group, we factor out the common factor A, leaving the binomial B minus 2C in the parentheses. While in our second group, we factor 5, leaving the binomial B minus 2C in the parentheses. Study carefully this answer. Now that we've factored out the common factors in each of our groups of binomials, we now factor out the common binomial factor. You must have observed that b minus 2c is a common binomial in our two groups. So, we factor that out as the first binomial factor of our polynomial. Our next problem will be to look for the second factor. To look for the second binomial factor, we copy again the expression we got from our second step and divide each of the terms by the common binomial factor that we got in our previous step. This means we divide A times the quantity B minus 2C with B minus 2C, cancel the common binomial factor, and get A as our answer. In our second group, we divide 5 times the quantity B minus 2C with B minus 2C, cancel B minus 2C, and get 5 as our answer. Doing this will give us the binomial A plus 5 as the second binomial factor we are looking for. Now that we have two binomial factors, we can now say that the resulting factors for the polynomial AB minus 2AC plus 5B minus 10C are the quantity B minus 2C and the quantity A plus 5. Of course, to confirm that our answer is correct, we check our answer by multiplying the binomial factors. Again, since we are multiplying binomials, the distributive property and the FOIL method can still be used. Whichever method we choose to use, we will end up with the answer AB plus 5B minus 2AC minus 10C, which is the given polynomial. Don't be confused if the terms are written in different order because we have the commutative property of equality telling us that the polynomials that we got are the same polynomials even if they are written in a different order. Let's see another example. Factor out the polynomial 12b cubed minus 15b squared minus 16b plus 20. We begin by grouping together the terms. Again, you can have a different grouping besides the one shown here, but for this solution, we have 12b cubed minus 15b squared as the first group because their common factor is 3b squared, while we have negative 16b plus 20 as the second group, with 4 as their common factor. After grouping the terms, we factor out the GCF of the group terms. As we said, the first group has 3b squared as its GCMF. So we factor out 3b squared, which leaves 4b minus 5. In our second group, we factor out the common factor 4, which leaves negative 4b plus 5. Did you notice anything? If you remember in our previous example, at this point of the solution, we saw that the binomials inside the parentheses should be equal because that should be the first binomial factor of the polynomial. But here, they are not. So what do we do? Don't worry, we can make them become equal by multiplying negative 1 to the common factor 4 so we can make negative 4b positive and positive 5 into negative 5. Do we now have a common binomial? Yes, we do. So we now proceed to the next step. Now we factor out the common binomial factor. This is the reason why we had to make the binomials in the parentheses equal. Because 4b minus 5 is now the binomial factors in both groups, We can now factor it out and have 4b minus 5 as the first binomial factor for our polynomial. We now solve for the second binomial factor of our polynomial. We do that by taking the expression we got in our second step and divide both of the terms by the common binomial factor. If we divide correctly and cancel out common factors in our terms, we are left with 3b squared minus 4, which will now be the second binomial factor for our polynomial. Since we now have two binomial factors, our factoring is complete. Therefore, the factors of the polynomial 12b cubed minus 15b squared minus 16b plus 20 are the quantity 4b minus 5 and the quantity 3b squared minus 4. Of course, our solution is not complete without the checking. To confirm that our factors are correct, we multiply our binomial factors. If you do the multiplication right, either through distributive property or FOIL method, you will see that the resulting polynomial is the same as our given polynomial. Good job for solving the factors! It's time to practice what you've learned. Factor out the polynomial CD plus 7C plus 5D plus 35. Pause this video for a while as you solve for the binomial factors. Done? If your answer is the quantity C plus 5 times the quantity D plus 7, then you are absolutely right. If your answer is different, look at the solution again to see where you went wrong. Good job! Congratulations for finishing your video module. We hope that we have made things clear for you. If there are some things which are not, then you can always rewind this video, read your module, or ask help from your teacher. Always remember that your learning is in your hands. Benjamin Franklin once said, "An investment in knowledge pays the best interest." So, continue investing in your learning, stay safe and healthy, and we'll see you again in our next video module.